I'm recording right now.
Okay, begin luôn hả?
Yeah.
Okay. So I'm talking about neural networks. Definition: neural network is a set of algorithms that are designed to recognize patterns in a set of data, and the output will be calculated by the input multiplied by the weights. The neural network is used to recognize face, speech, or and sometimes it's recognize image and do the data compression. This is a basic example of a neural networks. We have input layers, and then the data we put in, we go through the hidden layers, and then produce the output. This one is more detail about how the neural network process the information. We have the inputs and the weights. The weight is a value that we use to calculate the activation during the process of training. So we will here we will use some function to multiply the input and the weights to calculate the activation here. And most of the time, the weights can be changed and adjust during the process of training. So we talk about network architecture. There are two main feed-forward networks and recurrent networks. Feed-forward network, there is no loops and produce only one set of output values. Here's an example. We have the input layers and the hidden layers, and then the output, and the data it just will forward from the input to the hidden layers, and then go and produce the output. There will be no loop inside the network. However, the recurrent networks, there will be loops in there because of the feedback connection, and the output of recurrent neural networks depend on the prior elements within the sequence. So, for example, there is will like this, but during the hidden layers there will be a loop. So the data will come back to the prior elements to test the calculation, and the recurrent networks will mostly used in the language translation and the speech recognition, while the feed-forward will be used in handwriting and data compression.
Okay. So for previous slide, so for this right now we're focusing more on the left one, the feed-forward networks, just right now. Because for the recurrent networks, it's a little bit more advanced, and you will learn later. It's mostly it's one of the first motivation for the transformer, which is used in ChatGPT right now. But for
Yeah,
now, just focus on the left one, the feed-forward networks.
yeah. So the feed-forward network, I use this as an example here to explain more. It's an example of the feed-forward network. So we put in the number 9 as a input here, and then the number 9 is produced by the each pixel here. So each pixel here will be associated with each neuron here, and then in the next layers, this will be divided into a smaller part, and each part will also be related to each neuron here, and then in the next layers, the network will combine each part into like a clearer picture. Like we will have like this each line here will combine to this circle, and from this one the network will predict the input is number 9. Yeah. So I will talk about how do we calculate the activation. Activation is each neuron here. So it's mostly will limited between 0 and 1. So we will use this formula to calculate it. We use the A1 multiplied by this is weight 1, and then add the A2 multiplied by the weight 2, and we will go on the process until the last neuron. And then we will use the sigmoid function to this one is just used to limit the value between 0 and 1. So 0 is black and 1 is white. So the ray color is represent the number between 0 and 1. So and that is how we calculate one activation, and we have to do the same thing for another neuron in the network. And this is just another way that we can use the concept of matrix and vector to calculate the activation inside the neural networks. And this one we can use the code to to portray this one. So we can use the matrix here, and this is the vector we can use, or we can do exactly the same thing here to calculate. So the training process is the process of making neural network to make a correct prediction based on the label input, and we have to make sure that the neural network give us the right answer for the input. So we have to teach the neural network doing that things. So the output is not always accurate. So what happens when the output is not right? We have to do the back propagation. Back, propagation is an algorithm that is used for error correction. So basically, if the output is not right, we have to go back and fix the hidden layers in order to change the output and produce the right one. And during the process of fixing the error, we use the concept of loss function to measure the error between the predicted outcome and the actual output. And this is just we calculate like how much error we have during the network, and we use the concept of radiant disease. We could calculate the slope of the function, and we would adjust the weight and the bias according to the lower point. So we just find the lowest point. The lower point is it means we have less error in the program. So yeah, we just do the same thing until we finally have the right output.
Yeah, so that's the loss function, and the main goal of training the neural networks is to minimize the loss function. And by the way, is in most cases is this is the whole function, right? And normally we want to find the absolute minimum of that the whole function. But that's also one of the problems we run in later, is that you can only find the local minimum with this gradient descent. So anyway, but yeah.
So we just find a lower point, not a lowest point, right?
Yeah, is our ultimate goal is to find the lowest point on the loss function. But computationally it's very tricky. And so most of the case we're just gonna find the local minimum of the function, but it's very hard to get the absolute minimum.
Oh yeah. Okay.
Yeah.
So and the neural network is used in many have many application in our life. For example, we can use it for the face recognition, signature or handwriting, recognize the signature and the voice or the speech, and we can also use it in the language translation and image recognition. Yeah. So yeah, that is all. This is short, and yeah, that's it.
Okay. Yeah. Awesome. Yeah, great presentation. Normally when you finish the presentation there could be like questions at the end. And then they're not going to really ask you a question at the end of your presentation, but well, I know everything already. Let's see.
Oh,
I can share with you something when I did. So mostly for the weekly meeting, just gonna share whatever we did across the week, right? The smaller updates than a formal presentation. So in this one, let's see what I did here. I watched this video. It's on Keras, and Keras is an API, very popular API for machine learning. And
mm,
for machine learning, you have two main thing is TensorFlow, and the other one is PyTorch. And in TensorFlow, we have Keras, which is previously another independent source API, which is Keras, TensorFlow, and PyTorch. But later, TensorFlow and Keras merged together. And this what I'm learning Keras right now, the actual coding, the machine learning. And for you right now, you in the beginning you just learn the overall picture of machine learning first. They're gonna learn different models of them first. This is the big picture, no coding yet. And then once you get the big picture, you're done with that. You have the picture. Then you can go deeper to understand the mathematical function and how do you do the loss function, how you do the gradient descent. And once you know all of that, then you go to this actual coding. I'm on like phase three already. Just sharing with you on the actual code. And then some of them may be a little bit too much for you right now, but it's okay. We just, expose it for now, and you will learn them eventually.
mm,
So I follow this video, and this is very basic coding. So first one, you're just gonna import a bunch of library.
mm,
And for this one is pretty interesting one, by the way. You have random.seed, and this one, what it does is you control the randomness of the code. So if you put like random.ran into something, then you can control the randomness in the code. This to make sure when you repeat the code, you get the same random result. In this one, just some stuff. Then this is my data. I'm generating data for this one. Normally you don't have to generate the data, so this one you're not related to this in the actual coding, in the actual application. This one I'm converting my generated data. And for this one, this one is very interesting one. One is GPU. So for coding or even just machine in general, we have a we have CPGU, which is the computer processing unit. So this one have in every single computer laptop. And then we have GPU, which is the graphic card. So we also have this in most computer. And then the last one is GPU, which is not very popular. It's mostly used in big company only. So GPU is the least strong one, so it's very weak. Its fundamental calculation it is a multiplication between two scalar value or just two numbers. GPU is based on vector calculation. So it's a vector multiplied by another vector. And TPU is based on matrix multiplication. So TPU is the strongest one, CPU is the weakest, and GPU is the middle one. For machine learning, CPU is oftenly not strong enough, and TPU is very unpopular. So in most cases, we use GPU for now. And this one, I'm trying to connect the GPU to the computer, and it did take me a while to do this. It's not that easy, but yeah. And then
So
yeah,
GPU is already in our computer or we have to install later?
uh, it's it's very likely that you have it in your computer already. The only thing is that does it compatible with machine learning?
Oh,
That's the only part that I'm not sure if it's like compatible with machine learning or not. And the second thing is I wonder how strong it is. Like for mine, it's only I think 4 GB, so it's not even that strong, but it's decent enough. Because if I use CPU, it can take like 4 or 5 hours to train the model, or even like the whole day. When you use GPU, it's a lot faster. But yeah.
uh,
You gotta look up your GPU and then just look up on the internet to see if it's compatible or not. And then this is the structure of the neural network. So I want to make this neural networks. What I do is I import all the library already. So this is sequential. So sequential neural networks is just the feed forward model one. So you go from left to right. Just go from left to right. You don't go. There's a lot of model, and sequential is just straightforward left to right. And dense layer, because beside dense, you also have convolutional and other things. So for dense, what it means is that you take into account all the neuron in the previous layer. For other product, for example, convolutional, you only take into account very specific neurons in the previous layer into account for the next neuron. And this unit is just specify the number of neurons in the first hidden layer. The input shape is you only specify for the first hidden layer because well that's where the input come in. So my input has a row, only one row, and number of columns you leave it blank. And when you do this, what it means is that it will automatically specify for you in the code. So when you feed the input in, it's just gonna automatically specify that for you. For the activation function, I use a rectifier linear unit, and rectifier linear unit is this function. If the weighted sum, which is if you take the input, you times the weight, you add the bias. If that value is less than zero, then you flat it out to zero. So whatever negative number is equal to zero after the activation function. If it's a positive number, then you keep it the same number. And the benefit of this is that it's very um, light computation only. So it's very easy to compute and it takes less time to compute because the function is very simple. And this is another way to note this function is that we take the maximum between zero and the value. So if you get a negative value, zero is bigger than that negative value. So you take zero. You get a positive value. This positive value is greater than zero. So you take the positive value. And that's the activation function for this. And for the activation, oh yes,
Is it the same as the sigmoid or function or just like
it sigmoid is also another activation function. So there
oh,
are multiple activation functions. And for sigmoid, the thing about sigmoid is that it does take into account negative number. So that's the good point of sigmoid
mm,
compared to rectifier linear unit. For sigmoid though, it's a little bit more computational heavy, and also it have an exponential problem because you're doing, but this one is normalized already. The sigma is just exponential, the whatever value you exponential it, and you get the exploding problem where the values become too big. So what they did is they scale it down to 0 and 1, and you have the sigma. But for activation function, the main point of activation function is just when um, you run through the neural networks, and mostly you do matrix multiplication. That's still linear, and you add the bias, and then it's still linear, but the data is not always linear, and sometimes they're non-linear, and that's why we have activation function to make them non-linear. And then this one, I specify the Adam optimizer, which is just stochastic gradient descent, just very regular, basic gradient descent. And then the learning rate is 0.0001. For the learning rate, if you set it too high, the learning rate is mainly related to the loss function. So you're trying to find the minimum point on the loss function. So if you set the learning rate too high, it is going to jump too much and it failed to find the loss function. But if you set the learning rate too low, then it takes too long, too many steps to go from the initial weight to the global minima of the loss function. So you have to put a reasonable learning rate into the model for loss. I use a categorical cross entropy. And this one is very popular loss function used for when you want to identify, for example, is the image a dog or cat? Then this is very popular loss function. And this loss function use logarithm, so it's a natural log actually. So if you get the point of the thing about this loss function about the natural log is that if you get it correct, then even you get it correct, but it doesn't mean you absolutely think it's correct. It's just the prediction of a probability. And if you get it correct, it doesn't penalize it too much. But if you get it incorrect, then it penalizes a lot for this loss function. And then for metrics, I also measure the accuracy of the model. So I run the model summary just to see how the model worked out. And you see this one is none because I put it blank here. So I don't specify how many input neurons going to have in my model. And then the first hidden layer have 16 neurons. This one is none, but then it will automatically specify 16 when we finish with this. And then the second hidden layer is 32, and the output is going to be 2, so only 2 output for this because it's identified. And then this is where you train the model. So you fit the model with X is uh, the the train value, and then Y is the labels that we're gonna put into the input. And then this one is not so important, but this one is just a validation. I just test the model with a separate data, but that's not so important. The patch size is how many input you're gonna put inside a batch. And then the epoch is how many times are you gonna run the patch. So we have 30 epoch, gonna be 30 times the epoch. And then inside the epoch, that's gonna be a batch, and the patch size is 10. So technically you run 30 times, and each time you run 10 input at a time. Then just sub for it, true. And sub for true is in the default, and I just put it here. And verbose is just how many information you want to show in the output. You want to show like most of them. You can set 0, 1, or 2. And 0 is that you don't want to show any information. 1 is you show a lot this information, and 2 you show more information. And then this one, I'm testing my model. So I regenerate new data. And then I run through this model again just to predict. And then this one I just print out my prediction. And I route the prediction to get the actual prediction. 0 and 1, 0. So for this, it is a probability distribution. If you add them up, it's going to be equal to 1, 100%. And then when I just route them, become either 1 or 0. And then I make the confusion matrix, which is the important part, is the confusion matrix. So this plot, you have the code, like this one is pretty popular. You can just copy and paste from Google or something. But the main part is to read this graph. In this graph, you're going to see, this is the very simple graph, but you're going to see it in most machine learning paper. You're going to have this graph, and then there's going to be a square, and there's going to be a label on the x-axis and the y-axis, and the diagonalized one from top left to bottom right, they are the correct one. And those are going to have higher numbers, or like, I can show you on that actually. This confusion matrix. And then based on the confusion matrix, and based on this diagonalized line, you can tell how good is the model performing. You're gonna see it a lot in this machine learning paper. Something like this, yeah. And then this is analysis. stuff that you can save your model. Instead of this, when you train, it takes hours. So you don't want to retrain it every single time. And one of the way you do it is that you save your model as an H55 in your computer. This one is this the command will save everything in the model, including the weight, biases, activation function, optimizer, and everything else. And then for loaded, you just simply import the library and load the model. So it's very simple to save and load the model. This one is for save the architecture only. And it's pretty much the same thing. You can save it and then you can load it. This one is save the weight only. So still the same thing. You just save the weight into this file and then you load the weight. And that's pretty much it. Yeah, that's it.
Oh,
Yeah. Yeah. Anything else? You have any question?
I think good. Oh, do you have the link of the YouTube that I want to like?
Oh, the link of the YouTube. I'll show you. Yeah. This one?
Yeah.
Okay.
No. Oh, it's okay. I can remember the name. Oh.
I'm gonna paste it anyway. Yeah.
Cut the cable with Verizon.
Yeah. Okay. Stop sharing screen. And then stop the recording.